This paper introduces a new image captioning bias assessment metric, called ImageCaptioner square. The most recent bias metric, LIC, utilizes a language classifier to assess bias in the generated captions. Measuring the bias using language classifiers introduce two significant drawbacks. 1. Degrading the captioning task to a text generation task, which is a flawed approximation, by ignoring the visual stream. 2. Does not match the underlying pre-training image captioning model we assess. Driven by these limitations, we propose a prompt-based bias amplification metric, termed ImageCaptioner square, that tackle the following questions. Can we regard the multimodality nature by incorporating the image while measuring the bias introduced by the image captioning models? And can we design a bias metric that better matches the underlying pre-training model we assess? To this end, we introduce our novel metric, dubbed ImageCaptioner square, which utilizes an image captioning model to assess the bias introduced by another image captioning model. In addition, we design a formulation for measuring the bias of generated captions as prompt-based image captioning instead of using language classifiers. This is an overview of the pipeline of our proposed metric, where two streams are utilized to evaluate an arbitrary image captioning model. The ground truth stream, in green, and the model stream, in blue. To measure the caption model bias BM with respect to the ground truth bias BD, we subtract both magnitudes, termed amplified bias. Given an input image, the associated ground truth caption, and the predicted caption, a text pre-processing module is utilized to refine the captions. The text pre-processing module performs two main functionalities: masking the protected attribute indicative words, and appending the prompt template to the caption. We hypothesize that if the fed captions are not biased, whether ground truth or predicted captions, then an arbitrary protected attribute classifier performance should be around the random performance. Therefore, masking the protected attribute indicative words is essential. For instance, if we are concerned by the gender bias, and the input caption is a man sitting in front of his laptop computer, then the output of the masking operation should be a mask sitting in front of mask laptop computer. Consequently, masking the input image is as vital as hiding the protected attribute indicative words. For instance, the persons in the image are masked to prevent all leakage sources, i.e., from images or text. We reformulate the bias measurement by introducing a prompt function from a classification objective to a text generation objective by refining the input caption by adding a predefined template. For instance, if the protected attribute is the gender, then the template which will be stacked at the end of the sentence will be therefore the gender is. And the model goal is to predict the next word. We verify the effectiveness of our ImageCaptioner square metric across 11 different image captioning techniques on 3 different datasets: MS-COCO caption dataset, Artemis version 1, and Artemis version 2, and on 3 protected attributes: gender, race, and emotions. In addition, we show more consistent performance against LIC on 3 consistency measures: conflict score, correlation score, and longest common subsequence score. Thanks for your attention.